super excited to be talking about the unexpected benefits of local first. We've been building Linear for 6 years now, and we started effectively with building it out local first with a sync engine. Literally, the first lines of code that I wrote was a sync engine, which is very uncommon to what you usually do when you're a startup. You usually start with the product. You try to sort of get product market fit with just ideas and throw it on the wall and see what sticks. But I was so set on sort of doing local first because first of all, who knows Linear? Awesome. Who uses Linear? Great. Half of the audience. Awesome. So for those who don't know us, we're a project management software. We try to be the standard in building software. We try to provide an awesome user experience for any product teams building software out there. My journey started in synchronization. I realized to my horror that I've been working with on 20 years with synchronization engines. The first one that I built was for a game that we did back in the day, effectively using Shockwave 3D, if anybody remembers that technology. And it was effectively just a real-time shoot 'em up game. And I built my first synchronization engine there. You had 8 players battling it out. The second one was when I went to China for a year doing games and animations for the local market over there, which was effectively the same kind of engine now for Flash and Unity. Then the third one, I had the chance of working at Groupon in San Francisco, and they had a point-of-sale application. Effectively, a restaurant would run an iPad app, take orders, or multiple iPad apps, and take orders and send them to the kitchen and swipe credit cards and so on. And I wrote a synchronization engine that had some local first aspects to it at the time, because we wanted to make sure that if the internet went down, you could still operate your point of sale. And obviously, to my horror, people, like we said, it should be sort of working for 5 minutes. And to our horror, one of our customers, took it on a train across the Rocky Mountains for 2 days without internet, swiping credit cards and taking orders, and hoping that once they reached, Wi-Fi on the other side, that it would sync them all up. And luckily, it did, because that was a huge bill otherwise to pay. Then I wrote one for Uber, where I worked thereafter, which never went live. We did a small prototype on it. Uber would be so much better if they had, adapted local first in their mobile applications. But I joined when, hypergrowth was going and the infrastructure was sort of set in place. So I really couldn't make it happen. It is actually open sourced. If you want to check it out, it's called Jetstream. If you search for Jetstream on Uber, we did have a Swift client, a Java client, a JavaScript client, and then a Node backend. It's abandoned. You shouldn't sort of look at it as a way to get ahead. But it was an interesting point. And when I then started working on Linear, I was set to sort of now really make it happen and take sort of all the experience that I had and make sure that I could create an application that was truly local first. Where I would just spend half a year up front working on the technology and make it work so that I could build a product. There's a few talks that I've given on the synchronization engine that we have at Linear. If you want to check them out, the first one explains effectively how the whole thing works, and the second one is sort of all the challenges that we've encountered when scaling up that sync service. But to give you a very quick primer on what the sync stack looks like, here's a diagram. The thing to know about or take from this is effectively we have what we call an object pool, which we load up from IndexedDB into memory at startup. And from that object pool, we generate a graph of model objects in memory. So you might have sort of pointers from certain model objects to others. An issue might be assigned to a user. A team might have multiple issues, and we take that raw data and just create a graph, a cyclical graph off of that data, so that what you effectively have as an engineer is at the top of it, you've got what we call the organization. We should call it workspace. And from there on, you've got teams, and teams have issues, and issues are assigned to users, and issues have comments, and so on. So you've got this one graph effectively sitting in memory that can be accessed synchronously. And we bind to that graph using MobX. So our views, if you render a page for a team that has issues, you would pass in that team model to the team page, and all of the model objects are observables in MobX land, and all of the views are observers. So when you render out any properties of those objects, if you loop through your issues, render out their statuses, their titles, MobX registers that these views are dependent on these model objects and their properties. So whenever any of the models update, the views automatically update as well. So in effect, what we get out of this is we don't really have to think about the binding anymore. Like, you render your views, and the moment the models change, the views render automatically for you. So what you effectively have is a very simple method of keeping everything up to date. And it really doesn't matter like where that update comes from. Like, MobX doesn't care. If the property gets updated, your views will automatically follow. And that is true for every single thing in the application. On the other side, you've got sort of the transactions that go out from making changes to those models. So if you want to change the title of an issue, you simply change the title of that issue, call save, transaction is created, sent to the backend, and the backend can then decide whether to accept or reject those changes. So we don't trust our clients, and in a synchronization engine, that is pretty important, effectively, if you have many clients out there. So the server does some validation on the inputs from all of our users. Make sure to sort of do side effects as well, send out emails, do some notifications, send things to Slack, and whatnot. So the backend can reject or accept those changes. If they get rejected, the backend just simply, or the front end simply reverts those changes, and again, your views update. So as an engineer, like, you literally just care about the object graph that you have in memory and the views that you render out of those. Everything else is taken care, for you by the sync engine. So you literally don't have to care about this when you create new functionality and new features. So literally, the object graph is what you're after. And I'm not going to go too deep on this. This sort of explains how the backend works. Look at my two talks if you sort of want to see how the backend works and what the challenges there were. So jumping into the benefits of sync. So when we started Linear, we thought that we had three things why we wanted to create a sync engine. There was obviously the performance benefits. If everything is local on your computer, there's no page reloads. Everything just happens in real time. When you click something, it's there. You can render it synchronously without having to wait for anything. The other one was real-time aspects of multiplayer. If you have multiple users using the application, any updates that any user makes will reflect within 200 milliseconds on your client as well. And the third one was offline. Like, we thought about this for a while, and still to this day, like, we don't say that you can or that you should take Linear offline for a week, make your changes, and come back online. Because in the end, it's a collaborative tool, and you're working with your team together on these things. We do allow offline for any amount of time, but it's merely meant for the flight trips that you take, or those moments where you just don't have internet connectivity. You want to check up something, you want to leave one comment. We do store all those transactions locally, and when you get back online, we send them over, and then everybody gets those updates. What we did not anticipate is all the other benefits that we would get out of a synchronization engine, and that's sort of the core of my talk here. The biggest benefit, really, and Martin alluded to this, is developer productivity. And you can have it today. If you have a synchronization engine, I think we've sort of unlocked, in my mind, some sort of cheat code. If you go back to any other architecture that where you have to sort of make your network calls yourself or handle those errors and do whatever, you're just so much faster at shipping functionality and shipping features with using a synchronization engine and building your application local first. I think we're pretty well known at shipping fast with a pretty small team, and literally, like, the core of it is that we have a great synchronization engine, and that our application is local first, which enables people to, or our engineers, to work on functionality very quickly. So the first thing is, we still have a backend, yes, at this time, and probably in the future as well, because again, we need to handle all of these side effects of changes that happen. But we don't need to write any network code ever again in our lives while we work at Linear. So this is a super simple example of just loading one JSON file from the server using it the old-fashioned way. Obviously, React 19 fixed this a bit, made it a bit easier. But this is what it was, in React 18, where you've got a lot of code to sort of, have state for your data, have state for your loading state, and state for your error, and you need to handle all of these three things, and you've got three different views that you need to render, depending on what the state of that load is. It's pretty cumbersome, especially if you have to do this every single time you want to mutate literally anything. So going local first, and with our sync engine, all of this is literally this. You have the data graph in memory most of the time, and you can just loop over it. So in this case, like you've got an issue that you're probably rendering at the moment. You access its comments, the elements of that comment. Like comment is a collection that we have. When you touch elements and it's not hydrated, or in our meaning, it means that it hasn't been loaded from IndexedDB or the network, it will automatically kick off hydration on the server side. So the first time you might access it, you might not get any elements. But the synchronization notices that you want to render some elements, so it starts putting them into memory, and 20 milliseconds later, it will kick off because of observation again, and your elements will be populated at that point. You loop over them, and you render out whatever you want. If the issue changes, if the comments change, if a comment is added, if the body text content of a comment changes, your component will automatically be re-rendered. So literally just 2 lines to show data from that object graph. I alluded to sort of hydration. We do have ways of offloading some of the data to sort of the backend, where like we don't want to load all the data in the first place into the client, because some of our clients have gigabytes of data generated for their workspaces. So we do have a way of making sure, if you want to make sure that when you render your component that you have actually the latest data, you can just call hydrate on literally anything, and it will either load it up from IndexedDB or it will go to the network and load everything up. And you can sort of resolve a promise which will cachify the promise that is being sent from the hydrate function, and then throw it, which will then called by suspense in React and render some loading screen, which in our case is usually just a blank screen because the load will happen very, very quickly thereafter. So 3 lines of code to make sure that the client has all the data that it needs, and then sort of loops over it and renders it out. Pretty simple. So how about mutations? Again, if you did this, it would be pretty hard. You would have to sort of generate a network request, send it out, wait for it to get back to you, figure out whether there was an error. If there was an error, you need to display that error somehow to the user and somehow revert your state back to what it was. Again, the synchronization engine should take care of that for you, and you don't have to think about these things. So if you want to change the title of an issue in Liner, you just modify the title, and then you call save. And because we're local first, like the moment you change the title, your UI will always reflect that. It will notice that the property was changed. It will look at its observers, and MobX will just re-render all the components that had it. So the moment the user enters something and changes the title, that title will appear in the application. Save will create a transaction out of that, figure out like what properties changed on that object, send them over to the server. Now the server can reject that change. It is possible. In this case, it wouldn't be like a title change will always go through. But if the server had downtime or there was some sort of other error, the database was locked up or whatnot, the server could say that I'm going to reject this change. And again, the sync engine will know what the transaction was, and it can revert the transaction. So it will set the title of that issue to the previous title. Your UI will update. A toast will be shown to the user. Sorry, you couldn't make that update. We'll display the error that the server sent without you having to write a single line of code. So error handling is taken care for you as well. And now we've got quite a few things that we don't need to handle anymore. Yeah, I mean, one of the big ones is no need to handle errors anymore. And here's an example of an error that might happen. I think like 99.99% of all of our transactions will just simply go through. It's hard to see here, but what I have is a issue creation dialog. I'm creating a new issue. I've got this drop-down open to change the status of that issue. And normally, there's nothing that can go wrong with this if you hit save, except if a different user makes changes to those statuses at the same time. Statuses can be deleted at any given point in time by admins or I think all users. So if somebody at the same time as you're creating an issue with a certain status deletes that status, and if that status deletion happens to coincide or happens to happen before your transaction is being seen by the server, then the server will reject that change because you can't create an issue with the status that doesn't exist. If you would receive that deletion while you're looking at this list, again, because all of our views are observing all the objects, that status would just disappear from your dropdown while you have it open, which is pretty awesome. So there's like this 200 milliseconds where an error might happen if two users make a change at the same time. And in reality, it probably never happens, because that's just such a small window where errors might happen. But you have the ability to sort of handle errors like these in certain scenarios. Like this would be a good example to have some manual error management, because the normal, regular way of the sync engine would be just to revert that change, which would be like just deleting whatever you just created, which is not great. If you wrote a good story, hit that save dialog and we tell you that nothing's gonna, it didn't save. So you, as an engineer, can manually revert that transaction somehow, bring up that same dialog again and say, oh, the status didn't exist anymore. Here, try again. So that's for error management. Literally no need to. I think in our application, and Linear is a pretty decently big application, we have maybe 15 places where we do manual error management, and everything else just always automatically handled for you. What you get all out of this is the ability to sort of prototype without any backend. You still need that backend until we get Martin's synchronization engine. But you can create any feature without ever touching the backend. So literally what you could do is, in the sync engine, you can say, I've got a new model. I don't want it to be sort of sent to the backend because there is no backend that exists for this yet. Because I don't know, what the schema should be. I'm just, still toying around with it. I'm figuring things out. And while you're working on it, you probably still want to sort of save those changes locally. So everything else will work perfectly. It will just not synchronize it to the backend. The synchronization engine will be like, well, OK, I'm not going to save it to the backend, but I'm going to save it internally in the IndexedDB because I'm circumventing this. It's a development feature. So you can keep on working on your functionality. You can try it out locally, and everything will just work. And once you're happy with the data schema, once you're happy with the feature, and once you fully develop the feature on the backend, on the front end, you can then implement the required GraphQL endpoints to actually save those data in the backend and expose it in the API. And have everybody sort of go at it. Obviously, you can't test sort of multiplayer things with it. But with that, we get to the last point. A local change is really the same as a remote change. There's literally no difference in it. Whether the user itself changes the title of an issue or whether somebody remotely changes the title of an issue, it runs through the same code path. You don't need to do anything. You don't even know where that change is coming from. It just automatically happens. And because your UI always updates when properties change, your UI will always follow regardless of how many users there are. So this makes it a very incredible way of building new functionality and building new features because you can just go ahead and build out what is important to the end user, which is the feature itself and the UI and how the user interacts with that UI. So developer productivity is a huge boon, and I don't think I'll ever go back to, well, I'm sure I won't ever go back to working in any other way. Like I think the benefits of working local first as an engineer are just so humongous that I wouldn't want to waste my time and spend my time handling network errors, making network calls. Whatever I do, I would be working on a local first architecture going forward. The last thing that we found as a benefit that was surprising to us that we didn't anticipate when we sort of looked at the user-facing features is infra benefits. We do have extremely low resource requirements. because everything happens locally. Every single page is rendered locally. If you compare it to, again, an old application that does network calls, every single page load needs to go to the server needs to return some data, or even some HTML, God forbid. That is a ping to a server every single time there's a user interaction. For us, we do bootstrap the data up front, which, yes, has quite a bit of a overhead, but we use caching and all kinds of layers to mitigate that. And after that, you have all the data. You can look at everything without making a single ping to the server, and only when you mutate things do you tell the server, well, I made this small change, and you get back a notification saying, well, the data is now this. Thank you. So, we can run with very few servers, the whole Linux stack. And to point this out, we just recently launched the European data center, just a few weeks ago. So, don't count into these numbers. You can't sort of guess how many users we have as a total, because we don't really want to tell. But we do have 1,000 concurrent users. There's a peak in midday. You see the last connected users graph here. So 1,000 concurrent users, which is approximately 10,000 sort of users in total, running on the European data center. Those big numbers are the number of pods we run in GCP for each of our services. We've got the API, the client API, our task runner, sync servers, and some authentication servers. And we've got 2 pods running for the task and the synchronization server, because we sort of want to have redundancy in there, and we always run with a minimum of 2. But it's not really visible, or maybe it is, because there's literally nothing showing up in those CPU graphs. It's running almost idle with 1,000 concurrent users, which accounts for 10,000 users of the application. And I did some calculations, and we could run all of Liner with effectively just 2 CPU cores in Europe, which costs you maybe $80 a month. So I'm telling you that the future is already here. You can save on server costs and those cloud costs by doing local first, because there's really not too much load that your service will have to bear. And that was what I wanted to talk about. Thank you.